Hello guys, how's it going? So this is the last meeting of March. This is our first meeting after the spring break. And the plan today is to go through a couple of examples using scikit-learn libraries and actually start doing something related to machine learning that we hadn't had the chance to do it yet. So I will share my screen. Okay. All right, so you should be able to see my screen now. Hope so. Well, the material that we're gonna use today is from a tutorial that happened on PyCon 2015, and that's the same material that was used on a video that I sent to you guys last week. So this material is really interesting because it starts from very foundation things. So we will have the chance to explore like concepts, especially for those of you who hadn't had any kind of experience doing machine learning code. So that'll be really helpful, I believe. The URL that you should use to download the code is on GitHub. Yeah, that's the one. This material is from a guy called Jake VDP. So you can use this URL to download everything if you want. If you prefer, you can also just open a new notebook, an empty one, and start doing your code as you prefer. The URL I'm talking about is here on top. Okay, so this code is on Python Jupyter Notebooks format. So you will have to have an environment that's able to run Jupyter Notebooks. After you have downloaded this, you can just unzip everything into a file, and the notebook interface will allow you to run any of these files that ends with the IPy notebook. It's an extension here. All right, so let me close this. Let me close this. Yeah, here I opened the session. These files are on my machine. So I can just click one of these and it will open to me. Let's go quickly through this snippet here. This is just to check the versions of libraries that you have on your system to be sure that you have the right environment. So in my case, I ran here and I got these outputs, but I didn't get an output for the Seaboard library. We can fix it really easily if you have the conda. So let's just stop for a moment to actually do that. So I'll have to stop my notebook currently running. And then I'll have to do a conda env list to check which environments I have currently. So these asterisks here, it marks the one that is enabled now. So that's the one called scikit-1. So if I want to install something, I'll have to specify that I want to specify on a specific environment, or if I don't specify, then it will just install on the current environment that is enabled. right now. So in my case, I want to install this one so I don't have to worry about it. So let's do a conda search Seaborn. It shows up. All right, there's a package called Seaborn, so I can just use conda install Seaborn. Wait for it to download. Oh, there's some dependencies that it will have to be installed also, and just hit yes and wait for the download to complete. And then the packages would be extracted and installed in the right places. Done. So now I can just start the notebook server again. Let me clear this screen. In my case, I'm using a shortcut, but you can just use like Jabber space notebook. It will start the notebook. Remember that the current path is important. So this is really important to check. Jabber notebook. All right, and we're back. Let me close these. We'll just locate the code that I had already downloaded. This one here. All right. Hey. Okay, and now I can do the same test again. Let's see if the Seaborn is now detected. All right, now I have Seaborn here installed. It's a good thing. You can also check the versions of the packages that you have. So this is a really neat way of actually checking what you have installed and also the version. If you want, can just like open a new cell of this and type it like directly, and it will return to you. Okay. All right. For this notebook, that's it. Let's go to the next one. Next one's called Machine Learning Intro. So here, if you guys, I'm not gonna go through every single line there's here, but you should totally read the whole content of this file. So here, there's a lot of things being explained about machine learning and scikit-learn in general. Dependencies that exist for scikit-learn, which is NumPy and SciPy. NumPy is like probably the most important dependency that you will for sure need installed on your machine. This first cell is important if you want the plots to be displayed on the notebook. It's important to run this cell here. Otherwise, it will not be displayed. Okay. I'll jump through this. I'm not going to go through this. That's just an example. So let's stop for a bit and talk about data representation in scikit-learn. When you have data that you want to feed into a model, then you will want this data to follow a specific kind of format. So this format is usually known as design matrix. So if you heard this term, design matrix, that's the term that we use to specify how the data is currently being represented. And these design matrix is a really easy way of representing data, which basically puts the data into a two-dimensional matrix. So we have columns and we have lines, and for each line that you have, it will relate to a sample. So it will relate to like an example from your data. For each column that you have, it will relate to a feature or a characteristic of the data that you have. So we will, in a moment, we will take a look at the iris data set, and we will see that each line that we have will represent one entity, one instance of my data. So you have like, if your sample has a size of 1,000, let's say, each of these will be represented into a line. So you can just take a look at the specific line. Let's say the third line would be the third sample from your data. The data set also usually is separated into training and testing sets, sometimes even in 3 sets. But I'm not going to talk about it right now. In a moment, we'll talk about it. Let's take a look first at this specific data set. So the data set that we are dealing with for a start is called the iris data set. And as the mention name, it's related to flowers and characteristics of flowers. So we have 3 kinds of these flowers called setosa, versicolor, and virginica. So each of these is a like a classification. I'm not sure if it is like a species. I'm not so good with biology, but you can think of different kinds of flowers, right? And the task that we're going to have in a moment is to choose to which of these kinds my current flower, my current sample belongs to. So what the model will try to do is basically classify to which family to which kind of flower my sample belongs. We have these nice pictures here, so you guys can check out. The iris dataset has these features. So these are a really small dataset. So by no means this is like a real world. I mean, this data comes from the real world, but this is not really used on a daily basis to actually do something substantial. This is more like a study kind of data set, and there's a lot of these kind of data sets. So in our data set, we have these characteristics, which we call features. So we have 4 characteristics, which relates to the length and the width of the sepal and the petal. And we have the classes, which are these 3, that each sample will belong to. So here, take a moment to take a look at this term. This is the term that we use to represent this term. Target is the term that we use to specify to which kind, to which class the flower will belong to. So when I was talking about the 2 kinds of sets that we have, the training set and the testing set, the basic difference between these 2 is that for the training set, of course, you're going to train your model with the training set, but the training set has a target which is known. So the target on the training set is used to actually train the model to predict which target it should belong to. On the testing set, you basically feed everything but the target to the model, and then it will come up with the prediction. You will take this prediction and compare with the target that you have on your data. So that's how we actually evaluate the prediction of the model. This is a really simple explanation, but we can go again and even give more detailed kind of explanation for what classification really is. But this is really just like the idea here is just to give an example and actually leave you guys take a look into a real code that does something with machine learning. So let's go to the code. In this case, this data can be easily loaded using scikit-learn's data sets. So it's a really neat way of quickly using quickly loading the data. You don't have to actually take a file and read the file, because the more usual way of dealing with data is to load the data from a file or a number of files. And this file usually is on a CSV format, comma separated values format, and you will have to process this file in order to have your information, your data loaded into your machine. So in this case, we will not worry about that. In the future, we're going to actually explore how to load CSV files and do this kind of thing. There's a lot of different alternatives to do that. So here I'm just importing this data. As a reminder, if you are doing this on your notebooks, you have to select the cell that you are currently on and use Control plus Return to actually run the cell. This is just a reminder to do that, because if you don't, if you forget to do that in a specific cell and skip like one cell, it might not give you the right results. I mean, the result on the current cell is dependent on the previous code that you run. Here we are creating a variable to store this data. This variable has 5 keys. So I have description, feature names, data, target names, and target. And the data itself is here on data and on target. So if I use like iris, if I do length of iris data, you can have a feeling of what the number of samples that we have. And here it is returning 150. So this is the number of samples that I have. An alternative way of doing this is how it is being done here. Also, you can do iris data shape. It will also return to you the dimensions of this data. So here on the first dimension that I have on this matrix, by the way, this matrix is a NumPy array. On the first dimension, I have the samples, and on the second dimension, I have the features. So this means I have 150 samples, and for each sample, I have 4 features. This is what is being done here on the next cell. So this is also one interesting way of using attribution, variable attribution on Python. Like if you have a sequence, also known as a tuple, or a function that returns more than one value, you can do this kind of construct to create more than one variable at the same time in a single line. And here I'm just basically just printing the values that I got from iris.data.shape. So no big deal. And if I actually want to take a look into the data, then I can use this construct .data and specify the line that I want. Remember that on Python, the index starts at 0. So the 0 would be the first line from my sample. If I want to check like the second line, I can do that. If I want to get, let's say, the first 3 lines, do that. So this gives you like an idea. When I have a really huge data set, this is actually common to do. Like imagine that you have a set with 50 million samples. So you will not print 50 million samples on your screen. So what you do is just take a look at, let's say, the 10 first ones. So you do this kind of thing. And this is called slicing. It's an easy way of doing this. All right, we talked about the shape already. Here, I'm also checking the shape for the target. So remember that my data actually has data key and the target key. So we talked about dictionaries before, right? So this key is actually being associated with a value. and this one is being associated with a different value. So if I want to access any of these, just use the dictionary name dot the key, so it will just retrieve what you want. It's kind of it's similar to how objects work on JavaScript, kind of. So you can use the same kind of understanding. All right, so same thing here. I'm printing the values for iris.target. So here he printed the 150 values. I could just, let's say, print the first n, reasonable. And take a moment to take a look at this. The way that scikit-learn represents the data is most of the time numeric. So for the classes, for the targets, I have 3 different possibilities, as we talked before. So each of these is actually represented by a number. So this is what the target will actually store. Let me print everything again so you guys can check. So here I see like a lot of zeros. That means these 0 represent the first class that I have on my data, which is Setosa. The 1 would represent the second, which is versicolor, and the 2 would represent the third class that I have. We also use targets and classes to mean the same thing. So I can call the prediction or the result of the classification as either class or target. It doesn't matter. It's the same thing. Okay, so I hope you guys by now have like an understanding of how this data is represented into this data set, and we can actually start doing some model prediction. All right, so in the next cell is when the magic starts to actually happen. We are still not doing any kind of model creation here. We are basically just printing the data that we have on a format that is understandable. So to be honest, I'm not so good with matplotlib, so I'll just skip through this, but you guys can take a look at this formatting that is used. It uses the scatter function to create a scatter plot, and then there's a lot of things that you can customize, like the kinds, the colors of the dots, how it is represented, the interval, the labels, these kind of things. If you have used R before, R has a really easier way of generating plots, but at the same time, it's not so diversified as Python. So Python, you have a lot of different, actually, a lot of different alternatives. All right, so we can go. Let me close this one, and we can actually go to the next notebook. Here it is saying that it's an old version of notebooks. It's being converted. It's okay. Don't worry about it. Okay, so here, let me see if I have the right one. Yeah, actually, let me use the next one. This is more a regression thing. Yeah, that's it. Yeah, let's use the notebook called 3.1 classification. So here, here we are going to use the support vector machine, which is a kind of a classification algorithm to try to predict the kind of petal that we're gonna, the kind of flower that we're gonna have. Where is it? Okay, this is what I want to show you guys. on scikit-learn, scikit-learn provides a lot of different algorithms to implement classification. So if you want to check that, you can actually take a look at the scikit-learn's documentation. So you can consult either the user guide or the API. Check the user guide and then go to supervised learning. And in our case, we are using a supporting vector machine, so it will be in this item here. So you can see the different alternatives that you have on scikit-learn, and it always, I mean, most of the time it provides examples to how to run stuff also. But this is like a user guide. So if you just want to check the possible function that you have, you will want to check the API. And then you can take a look at classification. Where are you? It doesn't, like, it's not so easy to find it, but if you take a look at it, you will be able to find what you're looking for. Like for supporting vector machine, go here, and you'll be able to see that there's a lot of options for classification. Take a look at these first 3 lines here. Okay, this is just for you guys to see, like, how to actually find something that you are looking for. Usually this is the way that I use to find, like, if scikit-learn provides a kind of function that I want to use, or alternatives, or which functions can I use to do a specific task. And if you want to check, like, the parameters, you can also, you click on it and it will provide a detailed explanation of the parameters. All right, so let's go back here to our notebook and actually run our model. In order for this to work, I have to have X and Y already in place. So let me just go back a little bit to see where it is being created. Okay, yeah, it's been created here. Yeah, let's do as I told, just run every single cell just to be sure. Okay, now I'm sure that I have X and Y. Oh, also there is this notation that is also very much used, the X and Y. For X, usually we understand as the input, and for Y, the output or the class that's going to be predicted. So this is also a convention. So most of the code that you're gonna encounter would follow this convention. Also, the fact that I'm using a uppercase X, that means that I actually have more than one feature. So I have like a 2-dimensional matrix, but not a vector. And if I have a lowercase like Y, it's just a vector of values. okay, this ran really fast. It's not always as fast as this. This ran really fast because our data is really small. This will, of course, depend on your data and also the kind of algorithm that you are using. So here I did a method that is called the fit method. This is probably the most common test that you're going to do for classification. Sometimes even for not only for classification, but basically for most of the machine learning tests that you do on scikit-learn, you're going to do a fitting process. So by fitting, what it means is that you are taking the training data and fitting the data into your model. So in other words, you are taking your model and you are you are making it learn the pattern that you want to by using this data, which is the training data. So the fitting process for the classification is basically that. After I had done the fitting, I can actually do some more interesting things like predict. Let's see. So here, let's see what's being done in this next cell. Yeah, this is actually a scatter plot that is trying to show the reasoning behind supporting vector machine. So let me just quickly try to explain what's being done. So from a graphical perspective, a supporting vector machine is basically a model that tries to separate the data into a split, into two different sets. So and by doing that, it basically it tries to find a line that is the best line that maximizes this area here, which is like a threshold that most of the samples will not cross. So as large as this area is, the better. So it basically tries to maximize this function. And this is what we call the supporting vector machine, because there's a supporting vector that's trying to do exactly that. Trying to do this split, this segmentation. I can do that for more than two classes, but each supporting vector machine actually does a binary split. So in order to do a multi-class, I mean more than two classes classification, I would actually have to use more than one supporting vector machine. And scikit-learn actually provides this kind of functionality under the hood for you, so you don't even have to know that. Okay, so let's try to see if there's predictions for us to check. Yeah, I was actually hoping to see the evaluation, like the accuracy. Yeah, we can let me go back here and let me create a small prediction for my object called CLF. I can actually use the predict function, and I can provide a specific value. So I would just pick a random value. I don't like the first line from X, and see what the prediction will do. So here it is predicting for my target for the first line, the first sample, to be 1. 1 is actually the second kind of flower that we have. So if you guys remember, if I do iris.data, what's it called? I can target. Oh no, there's only y. So yeah, actually this is not hard. So this prediction here, it's a match. You could also calculate on a more automatic way, like if you wanna know the accuracy of the prediction, you have to feed a like a number of samples, which would be the testing sample. So if you feed that, you can actually see what the accuracy would be. So we can actually try to do that. On scikit-learn, there's a package called metrics, if I'm not mistaken. Accuracy, yeah, accuracy score. And accuracy score is there's a shortcut that shows the documentation. Do you guys remember? For a function on Python, there's a like a shortcut that you can access the like it's like a header of the function.
Header of the function?
Yeah, like a description of the parameters.
You just see the first several rows of the data.
No, I mean for a function or a class. No, we can just check here the documentation. That will do the same thing. All right, so here's the function that I'm trying to use. This function calculates the accuracy, and I have to provide the true value for y, the predicted value for y, and optionally parameters that I'm not gonna specify now. So if I do, let's try to see if it works with one single value. Then we can try with more values. True one, predicted one. So the true one would be the 0, and the predicted one would be predict x0. Oops, something wrong. What is it? Okay. Yeah, it's complaining because it won't take a single value. So let's try to use actually a range of 10 values. All right. So here I'm getting an accuracy of 100% actually. I'm not so sure how this data was sampled. Let's try to use the whole set to see if it gets like 100%. So yeah, the way this data was sampled is not really a good way of checking the accuracy, because this data is being predicted at 100% correctly. So that's of course not always the case. And the way it is being sampled is by these functions here, make blobs. So I have not used this function before, but yeah, it's kind of restricted to 50 samples. We could let's do this. Let me try to actually use the same function to create an alternative testing set to see how it goes. So call it x test, y test equals make blobs. 250 also. Centers, DOM state. Let's do it 2. I don't know what that is. Cluster standard. I'll leave the same. Oops. Centers. Okay. All right. So now I have x test and y test. Now let's see how it goes with that. Here. See, now I have 50% of accuracy. A lot worse than the previous one. This is also interesting to actually stop and comment on these metrics. Like, we didn't talk about different metrics before. For now, we can just take accuracy as a like probably the most popular way of checking some kind of metrics for classification. Depending on your task, it might not be the best one. It really depends on the kind of test that you are doing. So as in general, for classification, accuracy is a good metrics. But you can see that from the same data set, I created an alternative sample, and this alternative sample is actually giving me 50% of accuracy. The previous one was giving me 100%. So by this, by looking at this, you can actually see how these things varies. So it's really hard to actually have a trustworthy measurement that you can trust, because the reason for you to have a metric is actually to try to predict how your model will behave for future unknown data. So this is kind of an impossible job to do. So there are techniques for us to try to have a more reliable kind of measurement. And in the future, we're going to talk a lot about cross-validation, and that's probably the most used technique to kind of counter these uncertainties that we have. But we can just stop now with this kind of reasoning. I mean, it really is a hard task, and at a certain point, you really can't be sure about what's going on, because there's a lot of uncertainties that we are dealing with. All right, for now, guys, I'm gonna stop here. I hope I was able to give a little bit of a taste, and you guys were able to have a bit of understanding of what's really going on. And if you guys have any kind of any questions, you can always send using our user group or Google group. And again, using the documentation from scikit-learn is really useful. So this is really helpful. All right, I think we can wrap up for today. Let me just stop the video. I hope you guys have enjoyed.